Our planet is facing a monumental challenge, one that touches every single one of us. By the middle of this century, the human family is expected to grow to nearly 10 billion people. All of these individuals will need to be fed, a task that places an immense and ever-increasing strain on our traditional methods of agriculture. The very ground upon which we have relied for millennia is showing signs of exhaustion. The great sprawling fields that have been our breadbasket for generations are struggling under the weight of our demands. The health of our planet's soil, the very foundation of surface farming, is in a state of crisis. The United Nations Food and Agriculture Organization, or FAO, has issued stark warnings, revealing that a significant portion of our world's topsoil is now considered degraded. This is not a minor issue. It is a slow-burning catastrophe that quietly undermines our ability to produce food. When soil loses its structure and nutrients, crop yields fall, and the land becomes less resilient. At the same time, another essential element for life is becoming alarmingly scarce: fresh water. For decades, our farms have drawn heavily from underground aquifers, vast, hidden reservoirs of water accumulated over thousands of years. But our rate of withdrawal has been unsustainable. Data gathered by satellites, such as those in the GRACE mission, paints a sobering picture of these subterranean reserves dwindling at an astonishing rate. In many of the world's most productive agricultural regions, these vital water sources are past their tipping points. Farmers are forced to drill deeper wells, expending more energy to pump less water, a desperate race against depletion. Overlaying all of these challenges is the pervasive and accelerating force of climate change. The global climate is no longer the predictable partner it once was. Rising temperatures, prolonged droughts, increasingly violent and erratic weather patterns now disrupt growing seasons around the world. These events are not just occasional inconveniences, they represent a fundamental threat to our food security. Scientists estimate that for every single degree of warming our planet experiences, the potential yield of major crops like maize and wheat could fall significantly. This climatic penalty makes the already difficult task of farming a precarious gamble, where a single heat wave or failed rainy season can wipe out an entire harvest, Faced with the mounting pressures on the Earth's surface, a truly revolutionary idea is taking root. It is a concept that turns our traditional understanding of agriculture completely on its head. Instead of looking out across vast open fields, innovators are now looking down into the deep, dark spaces that lie just beneath our feet. The proposition is as simple as it is audacious: to move a portion of our food production underground. This is not a return to a primitive, cave-dwelling existence, but a forward leap into a highly controlled, technologically advanced form of cultivation, shielded from the volatility of the world above. The core idea is to repurpose the hidden voids within our planet's crust. Abandoned World War II air raid bunkers, disused subway tunnels, exhausted mine shafts. In some cases, entirely new vertical shafts are being drilled specifically for this purpose, creating subterranean farms directly beneath our urban centers. Within these sealed and protected environments, every single element required for plant life can be meticulously managed. The chaos of weather, droughts, floods, unseasonable frosts. The farm becomes a self-contained ecosystem, a bastion of stability in an increasingly unstable world. This level of control offers another profound advantage: biosecurity. By growing crops in a closed environment, the constant battle against pests and diseases that plague surface farming is largely negated. Chemical pesticides, herbicides. This creates a cleaner, more pristine growing space, resulting in produce that is not only safer for consumption, but also grown with a lighter touch on the planet. Consistent harvest, predictable harvest, rapid harvest, located right in the heart of our cities, where the majority of people now live. This proximity to the consumer is a crucial part of the underground farming revolution. For too long, our food has traveled vast distances, a journey that consumes enormous amounts of fossil fuels and results in significant waste and spoilage. Thousands of kilometers, just a few city blocks fresher, more nutritious food reduction in carbon footprint. It is a vision of a future where our cities do not just consume, but also produce quiet, hidden, profoundly sustainable, To bring a farm to life in the perpetual darkness of an underground chamber requires a complete rethinking of the fundamental inputs of agriculture. In this subterranean world, the gentle rays of the sun, the soft caress of the wind, and the rich texture of the soil are all absent. They must be replaced, simulated, and in many ways improved upon through a suite of sophisticated technologies. These are the engines of growth, the artificial systems that provide the light, water, and air that plants need to thrive. Light, water, air. It is the careful orchestration of these technologies that transforms a sterile, empty void into a vibrant, productive oasis of green. The most obvious challenge is the absence of sunlight. Underground farms overcome this by creating their own suns in the form of advanced light-emitting diodes, or LEDs. These are not the simple light bulbs we use in our homes. They are precision instruments designed to deliver specific wavelengths of light that plants crave for photosynthesis. Complementing this artificial sunlight are soilless growing systems. Instead of planting seeds in dirt, these farms utilize methods like hydroponics, where roots are bathed in a nutrient-rich water solution, or aeroponics, where a fine mist of nutrients is sprayed directly onto the roots. These systems allow for precise control over the nutrients each plant receives. Another critical component is the environmental control system, often referred to as HVAC, which stands for heating, ventilation, and air conditioning. In a sealed underground space, air can quickly become stagnant, humid, and depleted of carbon dioxide. A sophisticated HVAC system constantly circulates and conditions the air, maintaining the perfect temperature and humidity level for optimal plant growth. It also enriches the atmosphere with carbon dioxide, a key ingredient for photosynthesis, often to levels higher than what is found outdoors, which can significantly accelerate plant development. This managed atmosphere is crucial for preventing the growth of mold and other pathogens that thrive in damp, still air. Finally, orchestrating all of these complex systems is the digital brain of the farm, automation, and software. It is simply not feasible for humans to manually monitor and adjust conditions for thousands of plants around the clock. Instead, a network of sensors constantly gathers data on temperature, humidity, light levels, and nutrient concentrations. This information is fed into a central computer that can make real-time adjustments, ensuring that every plant is living in its ideal environment. In the sunless depths of an underground farm, light is everything. It is the primary source of energy that fuels photosynthesis, the magical chemical reaction that transforms light, water, carbon dioxide into green, living plant tissue. Without light, there can be no growth. The solution comes from the light-emitting diode, or LED. Tiny, efficient LEDs are the artificial suns of underground farms. They provide precise energy so plants can flourish without a natural dawn. Plants don't see light like we do. They respond to specific colors, wavelengths, in the light spectrum. The light range that powers photosynthesis is called PAR. PAR falls mostly between 400 and 700 nanometers. Research shows a mix of blue and red light is especially effective. Blue light encourages compact, leafy growth. Red light drives photosynthesis, converting light into chemical energy. Modern LED systems are tunable. Operators can create a custom light recipe for each crop. They can also change recipes for different life stages. Some advanced systems add far red light. Far red with red can trick plants into shade and spur taller, faster growth. One of the most radical departures from traditional agriculture is the move away from soil. For thousands of years, we equated farming with tilling the earth. But underground farms treat soil as a liability. It can harbor pests and diseases. Its composition can be inconsistent. It is a heavy, messy medium to work with. These farms embrace soilless cultivation methods. One of the most efficient and futuristic is aeroponics. Born from NASA research, aeroponics delivers nutrients and water incredibly efficiently. Plants are suspended in the air, held by small collars, in racks or towers. Roots hang freely in a dark chamber below. There is no soil, no substrate, no standing water. High-pressure pumps force a nutrient solution through specialized nozzles, creating a fine atomized mist that envelops the roots. Droplets can be as small as 50 microns, so fine they hang in the air, coating every tiny root hair with minerals and water. The benefits are extraordinary, especially for water conservation. Water is delivered directly to roots, so very little is wasted. Any excess droplets condense and are collected, filtered, and recirculated back into the system. This creates an astonishingly efficient closed-loop water cycle. Compared to field farming that loses water to evaporation and runoff, aeroponics can cut water use by up to 95%. In a world where fresh water is scarce, that efficiency is a game changer, growing food in water-poor regions. Constant root exposure to air supplies abundant oxygen, vital for root respiration and nutrient uptake. Creating a thriving farm deep underground means becoming the master of its atmosphere. In the sealed, sunless confines of a tunnel or bunker, the air does not behave as it does on the surface. Without the natural circulation driven by wind and sun, the climate can quickly become stagnant, humid, and unsuitable for healthy plant life. Therefore, a sophisticated and constantly vigilant heating, ventilation, and air conditioning system is not just an accessory. It is the very lungs of the farm, providing the controlled breath of life that allows the crops to flourish and protecting them from the ever-present threat of disease. One of the most critical parameters that these systems manage is humidity. As plants transpire, they release water vapor into the air. In an enclosed space, this can rapidly raise the humidity to levels where harmful molds and fungi can thrive. The HVAC system works as a dehumidifier, pulling this excess moisture from the air. This captured water is a valuable resource. It is pure, distilled H2O that can be filtered and returned to the farm's irrigation system, further enhancing its water efficiency. By maintaining a stable level of humidity, the system creates an environment that is hostile to pathogens, reducing the risk of crop loss without the need for chemical fungicides. Temperature is another vital element. The deep earth provides a significant advantage here, as underground temperatures are naturally stable, typically remaining around 10 to 15 degrees Celsius year-round. This geothermal stability dramatically reduces the energy needed for heating in the winter and cooling in the summer compared to a surface-level greenhouse or vertical farm, which is exposed to extreme external temperature swings. The HVAC system fine-tunes this baseline temperature, keeping the farm within the optimal range for the specific crop being grown. The waste heat generated by the powerful LED lights can also be cleverly captured and redistributed by the HVAC system, turning a potential problem into a useful resource. Beyond temperature and humidity, these systems also manage the composition of the air itself, particularly the concentration of carbon dioxide. CO2 is a fundamental raw material for photosynthesis. On the surface, its atmospheric concentration is just over 400 parts per million. In an underground farm, operators can safely enrich the air with CO2, often raising levels to between 800 and 1200 parts per million. This carbon fertilization can act like a turbocharger for photosynthesis, significantly boosting the rate of plant growth. To achieve this perfect balance, a concept known as vapor pressure deficit is carefully monitored. VPD measures the combined effect of temperature and humidity and is a key indicator of how well a plant can transpire, a process essential for moving water and nutrients from the roots to the leaves. Running a modern underground farm is an exercise in precision and complexity, with thousands or even millions of individual plants, each requiring a perfect, unwavering environment 24 hours a day. The task is far beyond the capacity of human oversight alone. This is where the digital farmer comes in. Sensors, cameras, software, artificial intelligence that acts as the central nervous system of the entire operation. This digital layer does not just automate repetitive tasks. It provides insight and control, transforming agriculture into a data-driven science. At the heart of this system is a vast array of sensors: air temperature, humidity, CO2 levels, light intensity, pH of the nutrient solution, electrical conductivity, EC, leaf temperature. The concept of farming beneath our cities is no longer a futuristic fantasy. It is a present-day reality. Around the world, pioneering companies are repurposing dark, forgotten spaces into productive agricultural hubs, proving this model works in practice. These examples act as living laboratories, showing both potential and practical challenges. From the historic tunnels of London to the bustling subway stations of Seoul, green shoots are emerging from the gloom. In London, growing underground transformed a World War II deep-level air raid shelter into a commercial farm. 33 meters beneath Clapham streets, the tunnels now host a state-of-the-art vertical farm. They cultivate microgreens, salad leaves under pink LED lights. Their location lets them harvest and deliver to local restaurants and major retailers like Marks & Spencer within hours. In Seoul, Farm 8 uses public transit infrastructure to place high-tech metro farms in unused subway spaces. These farms produce fresh salads and greens, act as educational hubs, and operate retail outlets. Commuters watch vegetables grow behind glass, then buy a freshly made salad or smoothie from an adjacent cafe. This integrates food production into daily urban life, reconnecting people with their food. Green Forges looks ahead, building underground farms into new construction. They drill deep, small-diameter vertical shafts beneath buildings. Those shafts become fully automated vertical farms, forges. The building supplies customers, the farm supplies hyper-local produce to residents above. It's decentralized urban agriculture, production and consumption in one self-sufficient structure. While the promise of underground farming is compelling, a clear-eyed assessment must weigh its remarkable benefits against its significant costs and risks. This is not a silver bullet solution for all of our food system's woes, but rather a specialized tool with a unique profile of advantages and disadvantages. The success of this revolution will depend on our ability to maximize its strengths while diligently mitigating its inherent challenges. Only by understanding this delicate balance can we determine where and how this new form of agriculture can best contribute to feeding our future cities. The list of benefits is impressive, starting with dramatic water savings. By employing closed-loop aeroponic, closed-loop hydroponic, underground farms can recycle nearly all of their water, cutting consumption by 90% or more compared to field agriculture. This is a profound advantage in a world facing growing water scarcity. Yields are another area of strength. By stacking growing beds vertically and harvesting year-round, these farms can produce vastly more food per square meter of land than a traditional farm. A single acre of an indoor vertical farm can potentially produce the equivalent of hundreds of acres of conventional farmland, freeing up surface land for rewilding or other uses. Furthermore, the urban location of these farms offers a powerful logistical advantage. Placing production at the point of consumption slashes transportation distances, which in turn cuts carbon emissions, reduces spoilage, and delivers a fresher, more nutritious product to the consumer. The enclosed biosecure environment also means a drastic reduction in the need for pesticides, herbicides, appealing to a growing consumer demand for clean, chemical-free food. Finally, the earth itself provides a natural thermal buffer. moderating temperatures and reducing the immense energy load required for heating and cooling that plagues many surface-level vertical farms. However, these benefits come at a steep price. The primary burden is the immense capital expenditure required to build or retrofit these facilities. Stabilizing an old mine or drilling new shafts is a multi-million-dollar endeavor. The operational costs are also dominated by one major factor: electricity. The powerful LED lights and climate control systems are energy-intensive, making the farm's profitability highly sensitive to local electricity prices. This reliance on a constant power supply also creates fragility. A system failure or power outage can be catastrophic, wiping out a crop in hours. Lastly, we must consider the human factor. The potential psychological and physical health risks for employees working long shifts in an isolated, windowless environment. Underground farming is not destined to replace the vast fields of wheat, rice, corn that feed the world. Its role is more specific, more strategic, but no less important. It represents a powerful new tool in our agricultural toolbox, one that is perfectly suited to strengthening the resilience and sustainability of our burgeoning urban centers. As we look toward the middle of the century, the path forward for this technology must be guided by a hopeful but realistic strategy, focusing on its unique strengths while acknowledging its limitations. The revolution will not be televised. It will be cultivated, quietly and methodically, right beneath our feet. For investors and city planners, the immediate strategy should be to focus on economic viability. This means prioritizing high-value, short-cycle crops. Microgreens, salad leaves, herbs, strawberries offer the best return on investment, as their high market price and rapid growth cycles can help offset the significant energy costs. The business model must be built around this premium niche. Secondly, whenever possible, developers should leverage existing brownfield sites. Retrofitting abandoned tunnels, basements, mines is often more cost-effective and carries a smaller environmental footprint than drilling entirely new structures from scratch. The single greatest challenge is energy consumption. Therefore, a critical recommendation is to pair every underground farm project with a renewable energy source. Integrating farms with on-site solar panels, or locating them in regions with abundant and affordable wind, hydro, geothermal power, is essential for long-term economic and environmental sustainability. Simultaneously, continuous investment in R&D is needed to improve the efficiency of LEDs, pumps, and climate control systems. Alongside technology, we must invest in people. Designing workspaces that prioritize worker well-being through simulated daylight, fair shift rotations, comfortable break areas is not just an ethical obligation, but a business necessity to attract and retain a skilled workforce. By 2050, it is conceivable that underground farms could be supplying a significant share, perhaps 20 to 30%, of the fresh leafy greens, herbs, berries consumed in major cities around the world. They will likely exist as a diverse ecosystem of micronodes in building basements and megahubs in larger subterranean voids. They will not feed the world, but they will make our urban food systems stronger, fresher, and more secure. They will save vast quantities of water, reduce transport waste, and provide fresh, local produce year-round, regardless of the season or the weather. The quiet, dark spaces beneath our world are waiting. With careful planning and wise investment, they can become the hidden gardens that help nourish our future.